Hello everyone, welcome back to my channel. Today we are going to see very important and very interesting topic. The name of the topic is circle. Now, in this video we are going to discuss all the basic concepts of the circle. So we'll start with very basic concepts of the circle and make sure you watch this video till end, and if you like it make sure you share with all your friends. So let's begin with circle. See now students, what is basically a circle? So circle is nothing but it is a shape which consists of all points on a plane that are at a given distance from a given point. That means we have infinite point which are at a fixed distance from a given point. So here we have one given point, and from that given point we have infinite points at a fixed distance. Then a circle is formed. Now if you observe, all this distance are equal because all these infinite points are at a fixed distance. So if this one of the distance is 4 centimeter, all other distance will also be 4 centimeter. So this is how circle is made. That means we should have one point, and from that point at a fixed distance we draw infinite points and we get a circle. So my dear students, I hope everyone is clear how circle is made. Now let's see some related terms with this circle. See now, if you observe here, the fixed distance which we spoke just now, it was from a point. So this point is called as center, and this fixed distance is called as radius. So that means the center of the circle is the center point of the circle, from which all distances to the point on a circle are equal, and this distance which we draw just now is called as radius. That means the fixed point from which you are drawing infinite points, that the point from which you are drawn infinite point, that point is called as center, and this fixed distance is called as radius. So these are two important terms related with circle. One is center and other is radius. See now, suppose if we take 2 points on this boundary of circle and we draw a segment. That means a segment which is drawn by joining 2 points, any 2 points on boundary of circle, is called as chord. So chord is nothing but it is a segment which is drawn by joining 2 points. These 2 points should be on the boundary of the circle. So if we take 2 points which are on boundary of the circle and we draw a segment, and this segment is called as chord. So chord is nothing but it is a straight segment whose endpoints both lies on circular arc of the circle, or you can say boundary of the circle. Now suppose I draw one line. Here we just now drew a segment. Suppose I draw a line. If you observe this line also passes through boundary of circle. That means this line is also touching 2 points on boundary of circle. But this is not a segment, this is a line. So if it is a line, it is called as secant. So that means a segment which passes through 2 points on boundary of circle is called as chord, and a line which passes through boundary of circle is called as secant. I hope everyone is clear with difference between chord and secant. So secant is nothing but it is an extension of chord in a circle which is in a straight line segment form, which has endpoint lying on the circle. In simple words, you can remember, if it is a segment, it is called as chord, and if it is a line, it is called as a secant. I hope everyone is clear with chord and secant. Now, let's move ahead. Suppose I draw one more radius over here. So we have two radius over here. Now here, these two radius, if you observe, there are two radius which we draw just now from center. If we combine them, this is called as diameter. So diameter is nothing but 2 times radius. So 2 into radius, or you can say 2 times radius, is called as diameter. So diameter is length of a line through which the center that touches 2 points on the edges of the circle. That means a segment which passes through center and it should touch the edges of the circle is called as diameter. Or in simple words, you can say 2 times radius is called as diameter. Or more simpler word, you can say the longest chord. This is the longest chord that passes through center is called as diameter. So a chord which passes through center is called as diameter. Or you can remember 2 times of radius is diameter. Or you can say the segment which passes through center and touches the edges of the circle is called as diameter. So remember, this is very important. Diameter is nothing but it is 2 times of radius. I hope everyone is clear with diameter. Let's move ahead. Suppose I draw one line in exterior of the circle and it touches at one and only one point. So a line which is in exterior of the circle and it touches circle at one and only one point is called as tangent. So tangent is nothing but it is a line which is drawn in exterior of the circle but it touches the circle at one and only one point. So that means you can say a line that touches the circle at single point is known as tangent, and this single point is called as point of tangency. The point on which tangent meets the circle is called as point of tangency. I hope everyone is clear with tangent. Now, we'll quickly revise everything. So we have studied couple of terms over here. First we started with center, that is in between of the circle. Then we saw radius. Radius is nothing but it is the fixed distance from the center to the boundary. Then we saw diameter. Diameter is nothing but 2 times of radius, or you can say a chord which passes through center. Then we saw chord and secant. Chord and secant are basically, if you draw a segment which touches the boundary of circle is called as chord. If you draw a line which passes through boundary of circle is called as secant. Then lastly we saw tangent. Tangent is nothing but it is a line which is in exterior of the circle and touches circle at one and only one point. I hope everyone is clear with these 6 basic terms of circle. Now let's move ahead and see one very important theorem that is asked many times in exam. So make sure you listen very carefully. See, the theorem says perpendicular drawn from the center of the circle bisects the chord. See, whenever you have theorem, make sure first you draw a figure. So if you observe in this statement, perpendicular drawn from the center of the circle bisects the chord. That means here we have center and a circle. So let's start drawing figure by center and a circle. So let's have one circle and let's have one center. Let's mark that center as O. So here we have one circle with center O. Now, if you observe, it says perpendicular drawn from center of the circle bisects the chord. That means we should have a perpendicular from center which is bisecting a chord. So first we should have a chord. So let's draw one chord over here. Let's name it as AB, and it says perpendicular drawn from center. That means we should have one perpendicular on this chord which is drawn from center. So we have one perpendicular OM which is drawn on chord AB, right? So this was a given statement which we got from the statement, right? So let's write this in given. So in given we can say that there is a circle with center O and we have OM perpendicular to AB. Now what we need to prove, it says this perpendicular bisects the chord. Bisects means this perpendicular OM divides the chord into two equal parts. That means you can say we need to prove AM is equal to BM. This perpendicular is dividing chord into two equal parts. That means somehow we need to get AM is equal to BM. Now, students, we all know that two segments are equal or congruent when two triangles are congruent. That means we should have two triangles over here. Then we can say these two segments AM and BM are congruent to each other. Now, if you observe, we have drawn two triangles with help of construction. Observe carefully. See, AM belongs to one triangle and BM belongs to another triangle. So if you need to get this blue and green segments equal, you should get this blue and green triangles to be congruent. Only then you can say these two segments are congruent. Now let's try to prove these two triangles congruent. See, if you observe over here in these two triangle OMA and triangle OMB, if you observe, both are right angle triangle. Since we have OM as perpendicular, both these triangles are right angle triangles. So you can say angle OMA is equal to OMB is equal to 90 degree, and reason will be since OM is perpendicular to AB. Next, if you observe, they are hypotenuse. Hypotenuse OA and OB are also congruent. Why they are congruent? Because they are radius of same circle. The fixed distance, if one distance is 4 centimeter, second will also be 4 centimeter. We saw in starting. So you can say OA is congruent to OB and reason will be radii of same circle. So make sure you write hypotenuse, not segment, because it is an hypotenuse. So hypotenuse OA is congruent to hypotenuse OB, and reason will be radii of same circle. If you observe OM belongs to both triangles. That means you can say OM is congruent to OM, reason will be common side. Now we got our three elements. Now you can say these two triangles are congruent by hypotenuse side test of congruency. And if you remember, our aim was to get these two segments congruent, AM and BM. Since these two triangles are congruent, now we can say segment AM is congruent to segment BM. Reason will be corresponding sides of congruent triangle, that is CSCT. And hence we can say segment AM is equal to segment BM. That completes our first proof of theorem. I hope everyone is clear with this proof. If you want, you can pause this video right now and take screenshot of this entire proof so you can keep it with you for revision purpose. Right? Let's move ahead and see converse of this theorem. Now students, remember, converse means given becomes two proof and two proof becomes given. So the last theorem which we saw just now, we'll see converse of that theorem. Now converse of theorem says a line drawn connecting midpoint of chord and center of the circle is always perpendicular to the chord. So my dear students, if you observe here, this is quite a lengthy statement. So let's break it part by part. See, if you observe in this statement, it says it have a center and a circle. So let's first draw a center and a circle. So we have just drawn a circle with center O. Next, it says midpoint of a chord. That means first we should have a chord, then we will draw its midpoint. So let's first draw a chord AB, and then we'll draw a midpoint of this chord, that is point M. So since M is midpoint, so AM will be equal to BM, right? So let's write everything in given, what we just draw just now. So given says, so we have one circle with center O and we have midpoint, that is M. M is midpoint of chord AB, such that you can say AM is equal to BM. I hope everyone is clear with given. Now let's see what else this theorem says. This theorem says we need to draw a line connecting midpoint of chord and center of the circle. That means we should have a line which is connecting midpoint and center. Here midpoint is M and center is O. That means we should have a line which is connecting O and M. So let's draw a line connecting O and M. Now what this line does, this line is perpendicular to the chord. So you need to prove that this line OM is perpendicular to this chord AB. That means our two proof will be OM perpendicular to chord AB. Now remember students, how we prove perpendicular. See, perpendicular means the angle between them will be 90 degree. That means you can say this yellow angle and this blue angle, if somehow we prove these two angles to be 90, then you can say these two segments are perpendicular. So that means what we are trying to do is we are trying to prove these two angles to be 90. Now these two angles are 90. That means we are saying that these two angles are equal. That means first we'll prove these two angles equal and then we'll prove these angles to be 90. So once we get 90, we can say these two segments are perpendicular to each other. But to get 90, first we should prove these two angles to be equal. Now we all know that two angles are equal or congruent only when two triangles are congruent. That means we should have two triangles and we'll prove them congruent, and after that we'll get these two angles congruent. So we should have two triangles over here. See, now drawing triangle is very simple. We'll just draw two radius over here. So we have drawn two radius OA and OB, and we have got two triangles, two different triangles in which these two angles belong. Now somehow we need to get these two triangles congruent. Now if you observe here, AM and BM are already congruent because we all know that M is midpoint of AB, that was given to us. So you can easily say AM is congruent to BM. Next, if you observe AO and BO, these are radius of same circle. If you remember, we saw in first slide that whenever the distance are always equal, if one distance is 4, then other will also be 4. So you can say these two radius are congruent and reason will be radii of same circle. Next is if you observe OM. OM belongs to both triangles. That means segment OM will be congruent to OM, reason will be common side. So you can say these two triangles are congruent by SSS test of congruency. And if you remember, our purpose was to prove these two angles congruent. Now, since these two triangles are congruent, we can say angle OMA is congruent to OMB. Reason will be corresponding angles of congruent triangle, that is CACT. Now, these two, since these two angles are congruent, we can say angle OMA is equal to angle OMB. That completes our first part, first proof that we wrote in hint. Next, these two angles are equal. Now we should get this 90. These two angles should be 90 because we need to prove two segments perpendicular. So how we'll get these two angles 90? See, observe carefully. If you observe these two angles, they are forming one straight line, right? So their addition will be 180 degrees. Reason will be angles in linear pair. Remember, whenever two angles form one straight line, their sum comes out to be 180 degrees, and reason we write as angles in linear pair. Now here we'll do some changes, that is angle OMB, instead of angle OMB we'll write angle OMA because they are equal to each other. Next step will be, if you observe left hand side, OMA plus OMA will be 2 OMA is equal to 180. If you shift 2 on other side, we get angle OMA to be 90 degrees. So if one of the angle is 90, other will also be 90. That means you can say OMA equal to OMB is equal to 90 degrees. And since these two angles are 90, we can say OM is perpendicular to AB, and we got our proof. If you want, you can take screenshot of this proof also, so you can keep it with you for revision purpose. And I hope that entire video you have understood very carefully, very clearly. Make sure you like this video before going, and make sure you subscribe and hit notification bell icon to get notification, because from next video we are going to discuss very important concepts and very important theorems related with circle. So make sure you subscribe and hit bell icon so you get notified as soon as I upload next video of circle. Chalo, we'll meet next time. Tab tak goodbye. Take care. Bye bye.